Hey, Chad Tomaszewski, your Tridon Communications, TSI Today, back in the studio filming. And my third guest today is one of our own, Michael Ghazi, resident expert for land mobile radios, also our GM for our Edmonton location. And he's going to talk to us a little bit today about how he bounced a signal 13,000 kilometers. I'm Chad Tomaszewski, Chief Growth Officer with Tridon Communications. We're talking to industry leaders about the technology that's changing their business. This is TSI Today. Hey, Chad Tomaszewski back here with TSI Today. I've got Michael Ghazi here with me today. This is a different spin on us. Usually we have guests from outside of our organization, but today I brought one of our experts in two-way radio, right from our own organization based out of Edmonton. Michael, thank you so much for joining us today. Let's jump right into it. Tridon's been around since 1981, so what's that, about 42 years now, I think. When did you get your start with us?
Actually, in a month from now, it'll be 10 years.
Oh, wow.
Yeah, 2013.
So talk to us about your path. Where did you start? How did you get into playing with radios and to what you're doing today?
Sure. So after a bit of a rough start after high school, I found myself in the Royal Canadian Navy. I was a naval communicator. I was responsible for all of the intership, ship-to-ship, ship-to-shore ship communications.
That's a lot of ship.
It's a lot of ship. Lots of different technologies too. HF, VHF, UHF, SATCOM. I did the crypto, flag hoist, semaphore, flashing light, all communications.
All started in the Navy. And then where'd you go after that?
So after I got out of the Navy, I went to school in Camosun College in Victoria, BC. For a computer engineering technology diploma.
Yep.
I finished that and found myself over in Toronto working for, at the time, Kenwood Electronics Canada.
And most recently, you've noticed on your LinkedIn, you've got a new piece of education that you've just tucked under your belt. What did you just recently accomplish?
I just finished an executive MBA from University of Fredericton. Thank you.
That's great. That's a big accomplishment. A lot of work put involved there. I remember seeing you at the office many nights studying and everything else, so good for you. When we think about two-way radios, there's a lot of people that might just think that it doesn't have a whole lot of pizzazz, right? It's just a radio. But there's so much technology inside of it, and we get to do so many fun things with it. Talk to me a little bit about some of the projects that you maybe have been involved in the past, or a solution that you provided that you're really proud of, and you look back and go, wow, I did something amazing. What might be?
Sure. I think the first one was for my time in the Navy. And I think that was what really sparked my interest in communications overall. So we were on an exercise in just off the coast of Australia. And one of the things that we do is send I told you about the ship-to-shore communications. So we had to send data messages from the ship back to our home base, which was in Victoria, BC. So there's a couple of different ways to do it. You can do it by satellite, which is easy, or we can use an HF transmission. And HF is a really interesting old school technology. Because I actually used the ionosphere and the ocean to bounce a signal back and forth from the ship to Victoria.
How far was that?
13,000 kilometers-ish.
So you shot a signal off of the atmosphere,
yep,
off the ocean, and you were actually able to communicate something?
Yeah, it was a very short message. I think I counted 25 characters or something like that, and very low speed. So we're talking 75 baud.
So how long would that signal take to go that 13,000 kilometers?
Not very long. It's light speed.
That's insane. I came at you with what I thought was a fairly simple question. And it's very complex though. Like in doing that, even though that technology was a little dated in today's standards, it's a very complex solution. Are all RF technologies that complex?
They don't have to be. The trick with RF is that a successful communication depends on literally everything. So geography, geology, the time of day, the 11-year sunspot cycle, whether it's raining that day, if it's winter or summer, everything. So for the general user, they don't think about a lot of that stuff. Putting in a solution, you have to consider it. Right. So, but that's what Tridon does. We take all of that challenge, we bring it in-house. Our well-educated, skilled engineers and technologists can put a package of solution together, and our expert technicians can go out in the field and install it.
That's great. We've got a few radios on the table here. One of them is this fancy Kenwood one that we're playing here with. You've got a lot of familiarity with Kenwood. In fact, I might say it's your baby. You speak quite fondly of the organization, and I know why. It's a rock solid solution. A couple years ago, they had a bit of an evolution from NextEdge to NextEdge 2. Talk to us a little bit about those technologies and how that changed.
Yeah, so Gen 1 was obviously their first release of the platform. They actually released that one just as I was joining Kenwood in Toronto. So my two-way radio business career really started with NextEdge. NextEdge it's a digital protocol. It uses the FDMA multiplexing protocol. And Gen 1, it was a good solution. I think we get up to 48 sites, 30 repeaters at a site, so 30 channels at a site. And it served its purpose for a lot of years. And now they've evolved to Gen 2. Gen 2, I think it's 1,000 plus sites, way more horsepower in the infrastructure and the protocol. But at the end of the day, it's still Kenwood, still NextEdge.
Cool. You said an acronym there, FDMA.
Sure.
And a lot of our viewers probably glossed over and go, another acronym in the telecoms business, my goodness.
Yeah.
But in the radio side, there's really three that we pay attention to: FDMA, CDMA, TDMA.
Sure.
What's the big differences between them?
So all three of them, the two main letters in those acronyms are MA. That's multiple access. Okay. So what we're trying to do is squeeze more intelligence, more information, voice, data, whatever it happens to be. We're trying to squeeze more of that into a fixed amount of RF spectrum. FCC in the States, ISED in Canada, the International Telecommunications Union, they're trying to get everybody, manufacturers, users alike, to use less spectrum because there are more and more users coming on all the time. So FDMA, CDMA, TDMA, they're all different methods of doing that, of squeezing more information into a fixed amount of bandwidth. CDMA is code division multiple access. It's used a lot in the cellular industry. I'll be honest, I don't know a whole lot about it, but basically it uses a frequency hopping combined with more protocol generated methods of layering multiple communications on top of each other. Okay. The two that I'm most familiar with in the two-way radio industry are TDMA and FDMA. So a few years ago, the FCC and then following on ISED mandated a change from 12.5 kilohertz channels to 6.25 kilohertz channels. And two technologies came up, or manufacturers split themselves into two camps. One camp using TDMA, one FDMA. So TDMA is time division multiple access. So what we do is we take that 12.5 kilohertz spectrum and we chop it up into time slots. Okay. I think they're 30 milliseconds, for instance. And in time slot 1, you put one voice path, okay. And in time slot 2, you put in the second voice path. And then the receiving radios will pay attention to the time slot that they need to get the message that they need. On the other hand, we have frequency division multiple access. And what that means is we take the 12.5 kilohertz spectrum and literally chop it in half and making two 6.25 kilohertz channels. And then each of those obviously carries its own communications. So there's pros and cons to both of them. On TDMA, we end up with less equipment. So because we're using the same channel, we can have fewer repeaters, less filtering, less cabling, lower cost for installation. But TDMA, because it's very time dependent, it's very dependent on the timing of the signal, multipath interference becomes a big problem. That's where the radio waves bounce off multiple surfaces and arrive at the receiving station at slightly different times. It can mess with the receiver. On FDMA, we don't really have that problem because it's not as dependent on the timing. But the issue with FDMA then is that you've got more equipment to get the same capacity of voice traffic that we had on TDMA.
That's a great explanation of that tech. Thank you very much for that. And I think that hopefully clears up a lot of things because a lot of people don't understand the differences between those three technologies. And I brought CDMA into it because LTE is becoming a thing of our future, whether we like it or not. We're seeing hybrid radios that have both of that LTE and an LMR solution built right into one. We're seeing cell phone devices that have the ability to push to talk. I don't think land mobile radios, push to talk, are going away anytime soon anywhere. They're just too centered on our needs, whether it's fire, life safety, first responders, police services, military, so on and so forth. And of course, what we're very fond of is the need in the oil and gas industry. One of the last questions I'd like to tackle with you is young people. And I think of Tridon, the involvement we have inside of charitable organizations and all the communities that we live and work in. A big push for me is to get young people involved and interested in inside radio. And you've actually had some experience in a different way. You've been involved with NATE in your past. What kind of courses could some of the viewers that are watching today take to get involved in all technologies, not just radio, but just technology as a whole? What might you recommend? So
speaking of NATE specifically, the two that I'm most familiar with is their Wireless Systems Engineering Technology program. So it's a 2-year diploma. They learn about all kinds of wireless systems, from LMR, cellular, all of the tools and equipment that they're required to use to design and troubleshoot those systems. Other programs they've got, electronics engineering technology, they focus there on the circuitry that actually enables radios to work. If you're not located here in Edmonton, there's SAIT in Calgary. I mentioned Camosun College in Victoria, BC. And there's polytechnics and community colleges all across Canada that have these programs.
Thank you, that's really good. Michael, if someone were to get a hold of you, how would they do that?
Sure, my email address at Tridon is michael.ghazi@tridon.com. And I'm on LinkedIn, just under my name.
Awesome. Thanks so much, Michael. It's great having you here. Thanks for watching TSI Today. Catch up with us next time when we learn more about technology changing business today.